Hello everyone, welcome back to my channel. As you know, I'm Lekil, and today I'll be explaining the research paper from the subject Big Data Analytics, whose subject code is 21CS71. So let's get started. Big Data Analytics using Hadoop. So what we are going to explore is the power of Big Data Analytics and how Hadoop helps us tackle complex challenges with vast data sets. So what is big data? So big data refers to data sets that are so massive and complex that traditional data processing methods are insufficient. So the four V's that we call are the first one being volume. Big data involves massive amounts of data, often measured in terabytes, petabytes, or even exabytes. Then we have velocity. Big data is often generated in real time, with new data arriving continuously from various sources. Then we have variety. Big data comes in a wide range of formats, including structured, semi-structured, and unstructured data. Then we have veracity. The reliability and accuracy of big data are crucial for meaningful analysis and decision making. So, what are the challenges of big data? Handling big data presents challenges due to its sheer volume, variety, and velocity. The first one being storage. Storing massive amounts of data requires specialized storage solutions that can handle high volumes and diverse formats. The second one being processing. Traditional data processing methods struggle to handle the sheer volume and velocity of big data, requiring distributed computing approaches. Then we have analysis. Extracting meaningful insights from big data requires advanced analytics tools and techniques to handle complexity and identify the patterns. So, let's get started with the introduction to Hadoop. Hadoop is an open source framework designed for distributed storage and processing of large datasets. Distributed storage. Hadoop's HDFS, that is the Hadoop Distributed File System, allows for storing data across multiple nodes in a cluster, increasing storage capacity and fault tolerance. Then we have distributed processing. The MapReduce programming model in Hadoop enables parallel processing of data across multiple nodes, accelerating analysis and handling massive datasets. The third one being scalability. Hadoop is designed to scale horizontally, allowing you to add more nodes to the cluster as your data grows. Then we have the Hadoop ecosystem components. The Hadoop ecosystem comprises various components that work together to manage, process, and analyze big data. The first one being HDFS, Hadoop Distributed File System. These provide distributed storage for large datasets. Then we have YARN, which is yet another resource negotiator, manages resources and schedules tasks across the cluster. Then we have MapReduce, provides a programming mode for parallel data processing. So MapReduce programming mode. MapReduce is a programming model used in Hadoop for processing large datasets in a distributed and a parallel manner. The first one we have map phase. The map phase processes input data and produces key value pairs. Then we have the shuffle phase. The shuffle phase sorts and groups the key value pairs produced in the map phase. Then we have the reduce phase. The reduce phase aggregates the value for each key, producing the final output. HDFS, Hadoop Distributed File System. HDFS is a distributed file system designed for storing and accessing large datasets across multiple nodes. So the first one being the name node manages the file system namespace and provides metadata about files. Then we have the data node. This stores data blocks on individual nodes, replicating data across multiple nodes. for fault tolerance. Then we have the Hadoop cluster architecture. A Hadoop cluster consists of multiple nodes, including name nodes, data nodes, and client machines. The first, the name node, manages the file system namespace. Then we have the data node, which stores data blocks on individual nodes. So there are multiple individual nodes. So each data node has separate data blocks, which is a separate information about that, which is managed by the each data node. Okay. Then we have the client who accesses data and submits job to the cluster. So a cluster refers to the multiple data nodes, which each data node having its own data blocks. Okay, so this client accesses the data. How does he access the data or submits the job sets? He submits them to the cluster, which divides the job and then makes them to the data nodes. Okay, so how do you access these clusters? By using the name node, which manages the file system's namespace. So the real world use cases of Hadoop. Hadoop has numerous real world applications across various industries. The first one being e-commerce, analyzing customer behavior, recommendations, and fraud detection. The second one being social media, analyzing user interactions, what are the trends, and sentiment analysis. Third one being healthcare, processing medical records, analyzing patient data, and identifying patterns. The fourth one being fraud detection, risk analysis, and market research, because these all are the things which are necessary in the field of finance. Whereas in the field of healthcare, managing the medical records, yeah, analyzing the patient data plays a crucial role. So, Hadoop ecosystem trends and innovation. The Hadoop ecosystem continues to evolve with new trends and innovations. The first one being the cloud integration. Hadoop is increasingly being deployed on cloud forms for scalability and cost efficiency. And real-time processing. Developments like Spark and Flink enable real-time data processing and analysis. Then we have machine learning and AI. Hadoop is being used to power machine learning and artificial intelligence algorithms for advanced analytics. So this ends my presentation. Thanks for watching.